Great. Well, good afternoon, everybody. Thanks for coming. Thanks for joining and listening to my talk. My name is Paul Davies. I'm an associate tech fellow with Boeing Research and Technology. We are the kind of central R&D organization for Boeing. We work across the commercial and the defense business units, and as well as our services business unit. I'm going to talk today. Last year at AWA, I kind of presented an introduction to BARK. BARK is the Boeing Augmented Reality Kit, and I kind of gave a kind of high-level overview of kind of what we're planning to do. And I think I showed one use case of our proof of concept in wiring installation using augmented reality. This year I'm going to go through the results of that a little bit, kind of tell you where we are now, show you how the BARK has evolved to other use cases, and talk a little bit about our roadmap and our plan and where we plan to take the platform. And of course, all of this pertains to aircraft manufacturing, products that Boeing builds. Generally speaking, that's our focus, improving our own processes, our own production lines in our own factories. So I wanted to start out and kind of show you some of the global footprint, how we're growing, how BARK is now, the development team is located, and also our stakeholders, which is our internal groups using the platform. You can see there in Southern California, our lab, I'm the project manager, we're all based in Huntington Beach. If folks are ever in the area, you want to come visit and talk one-on-one, just feel free to reach out. That's where most of our development team is. We've got a team of software developers there, an intern, and we have a lab there as well. We recently have opened a new, Boeing has opened a new engineering technology center in Korea, in South Korea, in Seoul. We have 4 developers there now who are working on BARK, and so we work with them every day. We also do work at the Advanced Manufacturing Research Center in the UK, and those are kind of the folks that generate the capability. On the stakeholder side, the users of BARK, as I said, are mostly internal, up in the Puget Sound region where most of our factories are the large factories, the biggest ones. We are using our tool to install wire harnesses. I'll show you what that looks like for locating parts and for installing parts. You'll see examples of those. In St. Louis, where most of our defense work is done, we're using it for part install, locating, and some training work. We have some external contracts we're working, and also in Philadelphia, we do a little bit of work, and in Charleston on the production line down there. So we've really kind of expanded from just a few people in one lab building a prototype to a kind of a global development team that kind of follows the sun in terms of cycles of development. This is the high-level overview of what BARK is. This chart has been sanitized slightly, but essentially the message is there. We've started with these 4 use cases. So we've got wiring installation, and I talked about that last year, and I'll show you an update today. Locating features. A feature could be a hole or a fastener, a clip, or any particular XYZ point. A technique to quickly locate sets of features. We've developed a capability there, which you'll see today. We have what we call BARK Part Viewer, which is a generic way for a user to upload content to a mobile device and view it in an AR scene, whether that be a wearable or a handheld device. And then we've got BARK Part Install, which is kind of similar to wiring install, but it has slightly different data sources, and that would be for installing firm parts like brackets, hydraulics, tubing, things like that. So we have right now we have a separate application for each of those. Those are the yellow boxes. They're all developed in Unity, and they run. Our ultimate goal is to have all of these capabilities deployed to different form factors, different pieces of hardware. By far, the most popular that we're using today is the HoloLens. Although we are the wiring install, we also have running on a Windows 10 tablet and also a Samsung phone running Android. Our goal is to make all of these use cases available on those 3 platforms that you see for wiring install. And that's generally because different users have different perspectives, different needs, and based on the job they're doing, the platform might be different. So we want the user to be able to just decide on their form factor of how they're going to receive that content and not be locked into one piece of hardware. Those applications all get their data from what we call BARK services, and that's where kind of all the all the hard stuff happens. That's running. BARC Services runs in our cloud environment. It's internal to our network. It's behind our firewall. It has a website front end that I'll show you that you can use to create content for any of these applications. And it converts generally speaking, it converts existing engineering data, whether it be a CAD model or some other type of design, into a format that's consumable by a mobile device inside of Unity. So that all happens, that's all automated on the services layer. And BARC Services gets its data from two places, one from the user. They want to enter job numbers or certain parameters that they need to build their jobs for the mobile device. But it gets most of its data from existing systems that we use in production, like an MES system, which is a manufacturing execution system, which is where all jobs are authored and stored, all work instructions, and we call them installation plans. And 3D data sources like CATIA. We have another system called 3DPI. There's many different places we store 3D data. So BARC Services will take data from all of those places. It will convert it, package it, and stage it for retrieval by any of these front-end applications that can then be viewed by the end user. And that whole process is automated, and you'll see that here today. I should just mention before I move on this chart, you notice the colors of the arrows. This is not complete. This is a work in progress. Like I said, wiring installed, you see the dark blue arrows, that's all complete, and I can show you that today. The other pieces we're filling in using the global team of developers to complete this picture. So this is not all finished yet. Just to expand a little bit on some of those use cases, so I've got some brief examples. So wiring install, talked a lot about that. This is a screen capture from a HoloLens of what that scene looks like. And you can see, I'll show you a video, but briefly you can see the user gets to select particular wires they're working on one at a time, and the system will filter the model and show just one wire at a time that they need to install. They can query the model by looking at it with using their gaze, and that's what that white box in the middle is, where it just gives you wire numbers. Just by looking at a wire, it'll tell you what number it is. And you can compare that with, we call it persistent call out. You can lock one wire number, compare it with another, see how those routes compare to each other and things like that. That's what's going on in the left-hand image there. On the right-hand image, that's called BARC Locator. And the data source for Locator is actually just currently it's a data file. It's not 3D, it's just a set of XYZ points. And as I mentioned, those could be holes or clips or anything that is useful. What Locator does is opens that data file and then populates the menus. You can see the user interface there. That's this piece here. It populates those menus based on what's in the file, and it allows the user to select different categories of locations. So let's say I had a wing that has many 1,000 holes in it that need fasteners, and some types of fasteners go in some holes. So you can say, okay, I want to see all of these types of holes. And what it will do is it'll assign it a color. As soon as you select what you want to see in that box, it'll assign that category a color, and it'll put a little pin next to the white box is the actual location, and the little colored pin corresponds with the menu, so you know what you're looking at. This is actually from a wing, what you're looking at there, and I'll show you a video of what that looks like in the factory. That's been very useful actually for our wing assembly as well as others. Third one, as I mentioned, is called Part Viewer. Now this is like a generic ability I mentioned. We believe like we're only scratching the surface of some of the use cases, and the 4 that we've identified are just the beginning. We wanted to provide a capability for anyone in the company to download and install an application onto their phone, onto their Android or Apple phone, and then go to our BARC Services website, upload some geometry, a CAD model of some type, and then go out to an airplane and align it and view it. And we think that could spur a lot of new thoughts and use cases. So this does not have any data connections to any MES or any production systems. It's just an isolated tool that a user, they have to bring their own 3D model. You have to generate your own content. You can upload it to the website, go out to the airplane and view it over the network, download it over the network and view it. That's what Part Viewer does. I'm sorry, that's Part Viewer on the right. That was the right-hand side. The left-hand side should be called Part Install. There's a typo in that title. Part Install is like wire install, as I mentioned, but for firm parts. So in this case, we would interface with a different type of MES system. But essentially, the goal is the same, to be able to help folks understand jobs and install things onto an aircraft. So this chart walks through what we call day in the life of the user of Bark. This gives you the steps that have to be followed in order to get that data from the MES or from the production system onto the mobile device. So first of all, somebody has to build the job. We call it building a job. In fact, what we're doing is really converting the data to make it available for the device. So a team lead or a foreman or somebody in charge of a shift would go to our Bark Services website, which is on the left there, and I'll show you that in more detail. They go here and they would build the job. So they would enter the job number, the aircraft program they're working on, whatever production program happens to be, and a line number. Line number is like the serial number or the tail number of that aircraft for effectivity. Once they enter that, as I mentioned, our tool will go off to the various production systems, gather all the data that it needs to build that job for the mobile device, and then convert it into a Unity asset bundle and stage it into cloud storage where it can be downloaded by a HoloLens or a tablet or a phone. That process can take anywhere between 5 to 10 minutes, depending on the size of the geometry. Larger models take longer to create asset bundles for. So there's a queue. They go into a queue, and I'll explain how that works shortly. Once the job has been built, it becomes available to the end user. So when the end user picks up a device, first thing they do is they also go to our Bark Services website, and they have to log on. Now, our authentication is two-factor. It's done through our Boeing badges, our smart badges, and you have a PIN. So they have to go to a computer, a laptop on the network, put their badge in, type in their PIN, which is a standard authentication for everything we do. Then they can get to our website, and it will show them a QR code on the screen like this. That QR code has their identity in it, but it also has a security token that is time expiring, which I'll show you. They take their device, HoloLens, tablet, they scan that QR code, and then that will then download all of that user's jobs for the shift. So any job that's been built for them, like I said, they get queued up here. You can maybe 2, 3, or 4 jobs in a shift. They all get staged and then downloaded at that point to the device. After they've downloaded, you can disconnect from the Wi-Fi and you can go do wherever you need to do. All that content is on the device temporarily. It doesn't get saved, but you don't need Wi-Fi after that. So then on the device, they would select, there's a menu, and it'll show you, okay, it'll say these are your installation plans, these are your jobs for the shift. They'll select the one they're going to work, and this is a wiring job, so you see all these wiring numbers. The next part of the process is to do what we call precision alignment, which is using our alignment tool, which is shown here. This is how we basically register the device in the aircraft, so that it knows where you are precisely, so that when we draw content, it lines up with the aircraft. We have added, I don't have an example of this, we have added what we call persistent alignment, which means now that the alignment only needs to be done once with this tool. After it's been done once, the same job does not need to be realigned. We use spatial anchors to, on the HoloLens at least, to be able to align automatically the next time. And then after that, the mechanic goes to work. So you see the content, whatever it is, parts, wiring, features, anything, and they can understand the design intent more accurately, and they can go perform their task. You'll see, I don't know if you can see it on that screen, there's a blue box right here. That's the bounding box that guides them on where, particularly for a wire job, where that work has to be done. Wire runs are usually longer than one job, one installation plan. And so the IP would be to write from a certain point to a certain point. We show that with the blue box, so they know the bounds of their job. What we're working on this year is being able to use the same tool for the QA inspector to come and buy off the job. We don't have that ability today. That's something we're working on. There are issues there around the level of authority that the data has. When we take a CAD model, which is NURB-based, and we tessellate it and decimate it for a mobile device, you're really changing the model, you're changing the surface. And we have to go through a process to make sure that our changes are not going to cause any loss of design intent, or the person building the job is going to be able to understand the design. Even though the changes are usually not visible to a person, right? Tessellating a model is usually still looks good. We have to go through an accreditation process to ensure that. So that's what we're working on. Once we get there, of course, our QA inspectors will also be buying off jobs using the HoloLens. Couple of other features. If the application, any of our applications, if they time out, this is kind of like a screensaver for Windows, is just to protect any proprietary information that might be being shown. If you take the HoloLens off and you set it down, you don't use it for a set amount of time, it will lock, and you'll need a PIN number to unlock it. And finally, a feature we've implemented, we call it blanking while walking. We use the device to detect when the person is actually walking through the aircraft, and we turn the display off so we can't, they don't get distracted or anything. And as soon as they stop walking, it just comes right back on. So all of our applications follow this same workflow. Whether, like I said, parts, wiring, features, other things, there's always a job to build, a QR code to download it, an alignment process. We have the safety features and the security features, the token and the QR code, all the same process. And that is what we call the BARC. Those componentized pieces are what we call BARC, and we can use those to build new solutions quickly, solve new use cases quickly. If someone, if a program said they needed to solve a wing body alignment join issue, we want to use AR. Really, all we need to know is where the content comes from. We've got the security, we've got the safety, all the other pieces are done. We would take those componentized pieces of code and deploy a new solution quickly. That's the goal of BARC. So I've touched on it briefly. It's also very important for us to maintain configuration control between the engineering design, the true engineering of the product, versus what the person sees on the mobile device. A lot, and we were doing this before, everyone is, manually converting any models, manually testing, sideloading content to a device breaks that kind of, that configuration control. So we have put a lot of effort in to avoid that. So what this chart is a representation of is how data gets from, in the case of a commercial airplane, from CATIA, where the design is done, to a Unity scene, say on a HoloLens, and that link is never broken. So in this case, like I said, engineering geometry, the translation is done by a large data translation service. That gets put into an asset bundle, which is automated on the BARC services layer, that red box, and then that's staged and downloaded to the device. If an engineer came in the next day and made a change to, say he moved a clip or something, or changed the design, the next time that job was built on our website, it would pull the new drawings over, and then that would propagate through to the HoloLens. So there's no chance of viewing old data on any mobile device. I'll also add, all of the jobs, when you do build them, across all of our use cases, they expire after 24 hours. So if you build a job one day and you try to download it, more than 24 hours later, it won't allow it. It'll say it's expired. And the reason for that is exactly shown here. We don't want the potential to download old content that may have changed. So we expire the bundles. And if you want to view it, then you just have to rebuild it, and then you can download it again. So this is very important for us. These are some of the, I showed this last year. I think it really helps to understand the gravity, the scale of what we're trying to solve. Even every time I walk in the aircraft, it's just simply amazing how they are built, how they do those jobs. You look at those, all of those wires, and looking at trying to understand a drawing like this. I've blurred it a little bit, but these guys, and trying to relate what they see here to which wire goes through which P-clamp, and it's just incredible. This was causing a lot of problems for, across all of our programs, really. Wiring install is one of the hardest parts of aircraft assembly. And so as we roll out the BARC wire install tool, we've shown significant improvements in the time taken and the quality. We generally have seen, we've done time studies of people using BARC versus those not using BARC. We've generally seen somewhere in the order of 20 to 25% time reductions for installing wiring. And almost 80% in first pass quality improvements. We saw defects drop off by around 80% when they were using a HoloLens in this particular study. So our plan is to expand this and roll out to other programs as well. I want to walk you through the back end briefly. This is what the website looks like, and this is all protected behind our badge two-factor authentication login. So to build a job, you enter your IP number here, your job number, your aircraft line number. You select a person over here. I had to obscure some of this data. So you say who's going to do that job, then you would pick some alignment points. The alignment points are what you're going to touch with that tool, that handheld precision alignment tool. These are the points that are predefined, and those are what you're going to go touch to align that content to the plane. They can be any points on the aircraft, you just need 3 of them. So typically we pick holes or something like that. After you've done that, you choose the program it's for, you hit generate, and then it will go into the queue, which looks like this. These are all the jobs that have been queued up and have been processed, and they all say complete. Some of them will fail occasionally, but in this case, I guess not. So you can check the status of your job, and usually we leave this running overnight. They'll all be built the day before for, say, the first shift in the morning. They'll be done the day before. It'll process them overnight, and by the time the morning comes around, they're all ready to go. Sometimes if one fails, it's most often not. It's actually usually a problem with the source data, like the IP has some missing geometry reference or something like that. So we've actually been able to use this to help them help programs improve their IPs. And these are what we call sessions. So these are the jobs that are ready to be viewed. On the Sessions tab here, these are the ones that have been processed and are staged in the cloud. And if you were to scan a QR code, these are the ones that would be downloaded to that device for that user. And there's a couple of them that are expired. So these are older than 24 hours. So they will have expired. So if you try to scan a QR code, it won't send you those. You have to go rebuild those to view them. And I mentioned the QR code. This is what it looks like for the user when they first log on. And you can see here the 60-second expiration. As soon as you generate the code, this starts counting down. You basically have 1 minute to scan it. And that's just to prevent people from printing it out and leaving it lying around. And other people will be able to scan it and get access to their data. If you scan this after 1 minute, the device will just report that it's expired. You need to log in again and generate a new code. This is kind of the way we propagate the security of our badges and our pins to the device that doesn't have a badge reader, basically. And so I mentioned on the device, most of our work is on the HoloLens. We really want to get to the point where it's device agnostic, and the same process applies to all of these. There's some nuances there, but we're working through. But generally speaking, when you pick it up, this is what you see. Scan the code. Downloads jobs, and then this is your IP list here. This is your jobs list. When you scan that QR code on the HoloLens, it would show you a list of jobs here. You click on the one you're going to do, and then you go out and perform your alignment. So I mentioned there's 3 points that you have to pick or touch, I should say, and that's one of them. It's a little, I guess it's a hole, and as the device recognizes this marker here. You see this menu that appears right on top of the marker, and you can say you're collecting point 1, 2, or 3, and then you hit a line, and then all of the CAD models will rotate and align to the aircraft. So I have a video of this, I believe. Yep, this is what the scene looks like on the right-hand side to the user. And in fact, I'll just skip this and jump right to the video. So this was taken from the first-person perspective, which is why it's a little bit, a lot of movement. But this is an entire, what we call a PI zone, entire section of the aircraft. All of those wires. One job, one IP would be to route a couple of wires. It would just be like 2 to 3 hours worth of work. So these are the IPs that have been downloaded for this particular user. And so based on his QR code and what was available for him and unexpired. So he's going to select one. When he looks back up, it's going to take away all the other wires. It's going to filter the model, so it hides all those wires that are not part of that particular installation plan, and just show the wires that are part of the IP. We call this data kitting. It's not a new term or anything. It's really removing all the data that's not needed for that particular job, helping him focus on what is needed for that particular job. And this is the source of some of the time savings, we think. We've completed well over 1,000, probably closer to 1,500 installation plans now using this tool just on one of our production lines. And we're in the process of scaling that now. We're going to have, not even sure exactly how many devices, I think somewhere approaching 100 devices on one of our production lines by the end of this year. And we'll be doing more and more of these jobs. There's about 2,000 jobs per aircraft, just for reference, on this particular program. And finally, I just wanted to show an example of the Locator scene, which was one of the other front-end use cases. I mentioned we're using it in wing assembly. This is a commercial airplane wing, and it has this was our first use case for Locator, by the way. It has an automated driller here that goes along and drills all these holes. That happens in phases. And between each phase, fasteners have to be reconfigured to hold the skin onto the structure. To help make sure all the fasteners are in the right place for that phase, we wanted an AR experience that would help them do a quick visual check where all the fasteners are and make sure they're in the right place. So that's where Locator was kind of born. You can see here all these little yellow dots. They've been updated, as you saw, with colored icons now. These are where the fasteners should be for this particular phase, and they're, roughly they're lining up. And here's an example of one fastener where it should not be. And so we actually use this tool to be able to detect that. The issue is if a fastener's where it shouldn't be and the driller comes along and tries to drill it, you're in for not a good day. This is the video of what it looks like. This is the newer version I said that shows the icons. You would load data, perform your alignment, again using the same process, the same alignment tool. This data is uploaded on the services layer on the website, all the same process, downloaded through QR code, and then imported into the app. And then as you select here, different categories, the drill holes, the centrix is a fastener. It's going to assign them a color, dark blue, green, so you can see which one's which. And then you'll be able to walk around the wing and do a visual check of where things are. You can actually see, just quickly see it, you can see it flicker there. That was because I started walking. I'm not sure if it was me, but whoever started walking and it blanked the display. So quite actually a simple use case, but very effective. We've got a lot of folks who are using this for different things now, not just holes, just helping visualize data sets. Okay, I've gone a minute or two over. We may have a couple of minutes. So that's my contact information. Feel free to send me an email. If you're in SoCal, reach out if you want to come chat. So.